Quadrilaterals. I love quadrilaterals. There's a lot of information about quadrilaterals that you may or may not know. I like how your book creates a hierarchy, kind of like a family tree of quadrilaterals. So it starts off in your book with drawing a picture of just a four-sided figure, because that's what a quadrilateral is. I'm not going to do a very good job of this, but so here I have a quadrilateral. It's not a specific kind of quadrilateral. It's just a four-sided figure. So that's a quadrilateral. Then what happens in the family tree is it comes down and it comes into this nice quadrilateral. That's not so nice because it's hard to draw with a mouse. But this one says, okay, this quadrilateral has opposite sides that are congruent and parallel. It also has opposite angles that are congruent to each other. So that's your parallelogram. Okay, that's our first main quadrilateral. Then from the parallelogram, it branches out in its family tree of hierarchy into this shape, which I'm sure you're familiar with, and then into this shape. So starting with this one, even though it doesn't look like it, this obviously is a rectangle. A rectangle has all angles congruent. So that makes it different than a parallelogram. It also has opposite sides congruent. That makes it similar to the parallelogram. For this one, even though it may not look like it perfectly, this says all sides are congruent, which is different than the parallelogram, but it does have opposite angles congruent. It has two pairs of acute and two pairs of obtuse, which is similar to the parallelogram. So if you think about it as a parent, you have a mom and a dad, and then you have certain characteristics that you got from your mom and certain characteristics that you got from your dad. And that's kind of what happened with the rectangle and the, what's this figure called? It's a rhombus. That's your rhombus, that's your rectangle. Now there's a third child that came into the picture in the very end, and it was this nice figure right here. That's your square. Your square took some of the characteristics of the rectangle, the 90-degree angles, and some of the characteristics of the rhombus, all sides equal, and that created the square. Okay? So I want you to look at that for a minute because this is an important hierarchy. It's important for you to understand how it processes. You can look at a square and you can see where it picked up some of its characteristics from each piece and then created this one shape. Off the side, because this is the quadrilateral, off the side of a quadrilateral, it's this poor little separate little shape, also a quadrilateral, but this is called your trapezoid. Your trapezoid, it's kind of like a little bit of a outcast of the rest of the group. It didn't pick up any of the characteristics of any of these shapes. It just picked up its main characteristic that it's a quadrilateral. Now trapezoids can look like that, or trapezoids can look like this, which I always say this is like a little minivan. It has a little 90-degree angles. Trapezoids don't have to have 90-degree angles. Trapezoids don't have to have congruent sides. The one thing a trapezoid does have is one pair of parallel sides, and that's it. If you look at all these, it has two pairs of opposite sides parallel. This has two sides, opposite sides parallel. This has two sides, opposite sides parallel, and this also has two pairs of parallel sides. Trapezoid, the only characteristic that it has is one pair of parallel sides. It's the only thing that a trapezoid has. It doesn't have any other characteristic with it. And if you looked at your textbook, you could see the hierarchy and have a better idea. Now, if you remember, a triangle sum of the angles of all the triangle is always 180 degrees. Knowing that, a quadrilateral can always be broken into two triangles. So if I know this is 180 and I know this is 180, then I know the sum of all angles of a quadrilateral is always going to be 360 degrees. So like the triangle, if I give you three angles, you can clearly find the fourth angle by simply adding the three together and then taking away from 360 to find your missing piece. So that's basically what we're going to do. We're going to classify and we're going to find missing angles. Starting with this. So I have 4x plus 110. So if I add all these together like this, and I say that the whole thing has to equal 360, I can use my algebra knowledge to put the information together. So all four angles equals 360. Put my 4x plus my x makes your 5x. Put 75 with 110 has 185. Go ahead and subtract 185 from both sides. 5x equals 75. Divide both sides by 5. X is 35. And so now you know the measurement of each of your angles, because the measurement of angle T, which was just x, is 35. And the measurement of angle R, which was 4 times x, is 140 degrees. So again, all you are doing is adding the angles up, just like we did with the triangle, but this time it equals 360 degrees. Same thing here. I'm going to do 120 plus 4x. I'm going to do 120 plus 40 plus 4x plus x, and then all equals 360 degrees. So I would have 5x plus 160 equals 360. And I'm go ahead and solve that two-step equation. Find out what x is. So here I have your 40 degrees. Substitute 40 times 4, and you have your 160 degrees here. And you can pay attention to it too. You can see this is obtuse and this is acute. So you kind of know you did it right when you look at that. Classifying. So if you look at this, I don't see any characteristics of this except for that it's a quadrilateral and it has only one pair of parallel sides. And therefore that makes that a trapezoid. This one, I can see opposite sides are congruent. I can see that opposite sides are parallel. This is how you do parallelism. You put like little arrows. Only makes this one thing. It can only be a parallelogram. I always say that a parallelogram is a rectangle caught in a windstorm, and a rhombus is a square caught in a windstorm. Somebody like blew it over or pushed it over. So there's a parallelogram. Obviously, that's a square. You have your rectangle, trapezoid, parallelogram. Easy. Good luck.